Hello, my name is Caleb, and my essential question is how can I use my love for robotics and art help me create something that both challenges me and helps me in a future career? I chose this essential question because in the future, I kind of want to follow a path as a mechanical engineer, something in robotics, maybe something in electronics. My essential question clearly encapsulates my want for either field, both having a significant part in creativity and hands-on experience. And since I have known what profession I wanted to go into, I've tried to follow certain paths in my life to achieve that. So I have prior experience in robotics as I've taken several robotics camps, including one at UC Berkeley and UPenn. I also partake in robotics at school, the course. On the more creative side of things, I've always tried to incorporate art into my life through art classes or extracurriculars outside of school. However, my idea for my capstone requires more of an electronics background, along with a coding background, of which I'm less familiar. I have done some coding, some Python and some Arduino, but I've never really been able to get the hang of it, while electronics is kind of natural for me. So some skills that I've had is the basics of electronics and what sorts of systems I require, inkling for creative projects and creative things from a mere idea or sketch, and I have some prior knowledge on coding and some 3D modeling. So, how did I explore my essential question? Well, I had an idea from a video game. This video game is called Skyrim. And in this game, there's an object that you pick up. It's kind of like a soccer ball slash sphere type of thing. I'll put up a photo of it right here. This thing is called Meridia's Beacon. And when you pick it up in the game, it says a voice line. It says something along the lines of this.
A new hand touches the beacon.
And it's really annoying. And I kind of wanted to create this. So my plan was to find out how I can sort of create something that when picked up or moved, activates LEDs inside of it and a voice line that would then say the voice line in the video game. And I would create the sphere through 3D printing. And so I explored this through 3D modeling on Onshape, which is a 3D modeling software that's free for all users. All you need to do is make an account. I've already made an account in the past, but I've never really, because I kind of wanted to get into 3D printing, but I have never had a 3D printer, so I couldn't. Coding on Arduino. Arduino is a coding website or coding app that's very easy to code on. Is compatible with a lot of things. Learning to operate Prusa Slicer. Prusa Slicer is a 3D modeling software that you export a 3D model to, and that creates sort of like a baseline of 3D printing, like as I show you here. And of course, learning to 3D print. So Mr. Louis, my robotics teacher, sort of one of my mentors, allowed me to use one of his 3D printers in his classroom, and I used one of my friends as well, who gave me access to a spool of filament. Filament is the thing you print with, for free. And I've been really happy about that because I didn't have to spend money on it or at all. So here's what it looks like in action, me trying to 3D print a prototype for the ball right here. And as you can see, it's just sort of it's printing the thing pretty slowly. And that's actually a problem I'll get to in a couple of minutes. So I've gone through Onshape, Arduino, Prusa Slicer, 3D printing, creating and finding electronic parts and circuit. Now I needed to find what sort of electronic parts I needed to sort of move to activate when it moves. I found this out to be something called an accelerometer, also known as an NPU 6050. And when moved, this thing records and understands, when coded, the acceleration that it experiences and can send a signal to something else. I also had to gain access to this something called a DF Player Mini, which is compatible with a micro SD card that plays an audio message through a speaker when there's something put on a micro SD. An Arduino Uno is what I used as the microcontroller, which is kind of like the mainframe, or like the main part of it. I have everything connected to an Arduino, and then I code the Arduino to then activate all of the things. And of course, LEDs. I chose red for my project, just because personal choice. I've also learned to operate several audio applications. I needed to download a app to record an audio, and I also needed to buy a micro SD card. I did not have one on hand, so I had to do that online and then upload my file to the micro SD, and kind of also learning the basics on how to create a circuit board. So when you put this in the sphere, I wanted it not to be able to come apart very easily. I'm using a breadboard for all of my electronics, and here's actually my circuit right here. And what I wanted to do, because through the breadboard it's very easy to take off wires, what I wanted to do was basically through through Mr. Louis recommended called BitTrace and Design Spark, I could create my own personal circuit board, and I kind of learned through that. So my initial goal was to have a completed and neatly finished project, but through the learning process, I had to create several stepping stones, so as problem after problem arose. So my first goal, after realizing all of this, was to learn how to 3D model and 3D print. I've had some experience, but not much, so I had to basically learn through YouTube on how to create a soccer ball type shape on Onshape, like this. This took a while just to figure it out. And then 3D printing, of course, which was pretty straightforward once I got to the hang of it. All you need to do is export your Onshape file onto a SD card, and then plug it into a 3D printer, and then it'll print with the filament attached. And then after that, was learning what components I needed and how to hook them up. That was a difficult challenge. I've had some electronics experience before, and I'm pretty good at understanding electronics, so I had to find my components and hook them up. I created a circuit in my notebook. Here are actually some of the notes from my notebook right here. And this is just some sketches of my project and what I wanted to do, and sort of a circuit idea on how to do it. And then my goal after that was just figuring out coding. Coding was the most difficult challenge of this because I had basically no prior coding experience. And so YouTube, best friend for this. I went through a bunch of channels learning how to Arduino, learning how to code the Arduino, and then I sort of set for myself in the margins. You're able to do this on our Arduino coding site, just putting some minor, like, explaining what this thing does and blah, 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 blah. I'll show you my code right now. I'm right here. I don't know if you'll completely understand it, but what it basically does is it tells the Arduino when the accelerometer is moved, this little device here, that when it's moved, just a little jostle, it will activate LEDs that will then pulse in a heartbeat type fashion, because I wanted it to be sort of like lighting up in all different things and having different brightness. And then I also needed it to access my DF Mini, or Player Mini, this thing right here, to activate a speaker that played my audio. And then after I hooked all of those things, my end goal was just having something I was happy with. After all of this, I had to overcome problem after problem, and I did finish with this. This is my sort of final project. That's it. When you move it, it then activates these LEDs that then pulse, and then it activates my DF Player Mini that plays the audio. And what you can kind of see is that my 3D printed half of a soccer ball type thing needed some light to pass through. So I chose white, as it is very easy to pass through, and some thinner things. So I went through a bunch of prototypes. As you can see here, to see what would work best, and I had a lot of problems with them that I'll get into. Basically, this video right here shows you how the LED will go through and will pass through the soccer ball to give it kind of a pulsing effect. So in the end, my goal was just having something I was happy with, and I am happy of this, that I could continue in the future. I had a lot of trouble and a lot of things I had to overcome and things I had to learn through the process, and it was just so fun through it all. I had made every component and just needed to put it all together, basically here, but I am sort of a perfectionist when it comes to these projects and just need more time to fully and meticulously finish it. But as of right now, I am very happy with the final project and the step that I took. And then also through this, I had to create, or I wanted to create my personal circuit board, or a PCB. I did this through Mr. Louis suggesting me these two websites calling DesignSpark and DipTrace. Now, in these applications, it's sort of hard to use on a beginner basis. I tried to watch some YouTube and I took a lot of time to try and learn this, but unfortunately I wasn't able to fully. Because during this, the electronic parts that I'm using are not common. They're not really common. So what I had to do was meticulously create them myself from scratch in this website. Like this. This is DipTrace, the PCB online sketch thing. And I had to create the accelerometer and the DF player mini. But they didn't look right. They don't look right in comparison to the actual things. The spacing of the pins are too much, and I needed this because when you're making a circuit board, you need the pins to be exact, because when you put in your electronic part, you can then solder it because there's copper around that. But if they're not the right width, you can't do that. And the Arduino that I'm using is not the same as the Arduino Uno, which is kind of weird, and I couldn't get over that, and Mr. Louis couldn't help me because this is something he knew of but didn't know how to use. Second was DesignSpark. After some time, I didn't want to give up on this idea, so I asked Mr. Louis again, and he suggested DesignSpark. However, this application wasn't compatible with my computer. It only worked on Windows, and I have a Mac. And the school computers don't allow downloads for this application, so I had to use my mentor's Windows computer at school. I wasn't able to take it home because it's his computer. He had a Windows, and I was able to use it. So he downloaded it onto his computer, and I was able to use it. However, he didn't also have that much prior experience. He used it like a couple years ago to create a PCB of some LED cube, but he hasn't used it since. And I tried to edit this cube with existing parts to create my thing, but that didn't work. So I've right here in my notebook kind of the PCB layout that I wanted to make, but I couldn't get it done. So after days of trying this out, I came to a point where I just accepted I couldn't make a PCB. And speaking of mentors, I was luckily in robotics, and my project being electronics focused was able to have Mr. Louis as my mentor. I asked him about it, and he was more than welcome to help me. My second mentor was YouTube and the internet. I have credited specific YouTube channels that I have followed through my process. I could have asked Mr. Wu about coding, but I didn't want to go through the hassle, so I instead used YouTube. There was also a student teacher during the time called Mr. Cote, who was a student teacher for my electronics class, and he helped me a bunch. He actually procured me the DF Player Mini as something he had just bought along with anything else. Like he had bought it, like he bought a couple, and when I brought up my project, he was like, "Oh, I could lend you one," and I was very happy about that. And I really wanted to credit him, but he is a student, so I don't know if I could make him my mentor. And so through my journey, I've documented through photos and videos to just showcase my process. So, some problems that arose during my project. First off, for OnShape, I couldn't create the actual Meridius beacon. As you can see, it has really weird shapes, and really, it's not a sphere, it's like a weird blah blah blah. So that was way too complicated for me to learn, and I didn't want to just take something from the internet and pass it off my own. I wanted to create this from scratch. So what I did was create half of a soccer ball through my process of learning, and all I would need to do is print two of these and stick them together to be sort of a soccer ball, sort of Meridia's Beacon type thing. I also had to struggle through learning 3D printing. 3D printing was one of the most annoying things that I had to power through. The printing, the supports on the actual thing were not working. As you can see from photos here, the supports wouldn't come off and they stuck to the actual, like they stuck to the filament, which wasn't supposed to happen. Supports are supposed to snap off very easily, but mine didn't for some reason. And I tried to talk to Mr. Louie about this, but he didn't know either. So I've kind of just powered through and kind of just went with it. Here, this picture right here is sort of the final half of one of my soccer balls that I've sanded. You can see it's still not perfect, but to the touch, it's very smooth. And this was kind of what I was going for. Another problem that I had to go was hooking up my accelerometer and DF Player Mini. These things were really difficult to hook up together. I kept having problems with one working and the other not, so I had to troubleshoot so much during my coding experience that finally I got it to work. And as you can see the video that I showed you early on, I got it to work and I was so proud of myself. And another problem was, of course, the PCB layouts. I couldn't get those to work. I couldn't understand what was happening with them, and I kind of just rolled with it because I wanted to create a personalized circuit board. I couldn't. It killed me to do this because if I were to put it inside this ball, it would just jostle around and some wires might come loose. But I just kind of went with it. And so all of this has been a learning experience for me. Learning how to use Onshape, learning how to use Prusa Slicer, learning how to 3D print, learning how to code and hook up all of my electronics, learning how to record audio onto a micro SD. I've never done that before. How to use a micro SD card with a DF Player Mini, which is the audio thing. How to hook up a speaker to play audio. How to use Dip Trace and Design Spark, and just so much more. These are basically all like some new skills that I've developed is just kind of getting a better understanding of everything. I had some understanding of coding, of electronics, but really I just earned so many new skills from this project. And this experience has really deepened my self-awareness and understanding of what field I want to go into and all of the challenges. Because I think this was a really good project to show me what sort of things I would work on in the future if I wanted to go into an electronics background or robotics background, because they're basically very similar. So I have just gotten a more deeper understanding because it's really just showed me what hands-on experience is like for this job. And I am loving it, loving this whole process. So I think I am going into the right field that I enjoy. And my key successes throughout this whole thing was being able to have a project that I was happy with. I was able to get it to work, and that was amazing. When this thing worked, I was shocked because I had so many things going wrong for me, and I was so happy to see it work. So, reflecting on where I am now, I knew nothing, not nothing. I knew very little about everything that I was doing, and in the end, I finished with a something so awesome. I finished with a working electronics thing that basically all you need to do is put in a ball, and when you activate it, it will work. So here is my design basically compared to the real thing. I think I did a pretty good job with the time and skills that I was given. Thank you so much for watching this video. I have learned so much from this project, and it has really showed me what hands-on experience I have to expect in college and even getting a job in this profession. I love what I'm doing, and I hope to continue it later in life. Thank you.